Hi everyone. Today we are going to study design principles in system analysis and design. Now there are certain principles that can be used for the development of the system. When we want to develop a system, we know that we design the system before we actually implement it. So there are certain principles that can be used for the design phase of the system before it is actually implemented. These principles are meant to effectively handle the complexity of process of design. Now, since the process of system design is a complex process, so in order to handle this complexity, we have these principles which can effectively handle such complex process of system design. What are these principles? These principles are basically the first one being problem partitioning. Problem partitioning, as the name suggests, is concerned with partitioning the problem. That means when we have a large and complex problem, we can partition it into smaller problems. So a bigger component or a bigger module is divided into smaller components or smaller modules. The divide and conquer is the policy which is adopted here. As we are dividing or partitioning larger problems into smaller problems, therefore we can say that divide and conquer is the policy. That means we divide a large and complex problem into smaller problems, and then we can easily conquer the system design process. The system is divided into modules that are self-dependent. As I said, a larger problem is divided into smaller problems. That means a bigger module or component is divided into smaller modules. And this division is such that each module is self-dependent. That means it is not dependent upon the other modules. It is necessary that all the modules have interaction with them. Although these modules are self-dependent, that means no module is dependent on the other module in the system, which makes them easier to design and reduces the complexity of system design. But at the same time, since these modules coexist in the same logical system, hence it is necessary that all modules have interaction with them. Just like we are a part of, just like if we consider a family of 4 or 5 people, where all 4 or 5 people are self-dependent. Nobody is dependent upon the other. The functionality of one does not affect the functionality of the other, but still they need to communicate with each other because they coexist in a family. In this similar manner, modules are also self-dependent, but since they are part of the same system, that means they need to have interaction with them. Now another design principle, the first one was problem partitioning. Another design principle is abstraction. Abstraction is an indispensable part of design process and is essential for problem partitioning. That means if there is problem partitioning, then there will be abstraction. It is unavoidable. So it becomes very indispensable part of system design if you are following the principle of problem partitioning. What is abstraction? Abstraction is basically a tool that permits the designer to consider a component. The designer here means the system designer. So it permits the system designer to consider a component or a module at an abstract level. That means from an outer view. If we look at any component from the outer view, that means we are concerned only about what that component is doing and not into the details of how that component is doing that functionality. So that means this is the meaning of abstract level. Without worrying about details, as I said, we are not concerned about how it is being done. We are only concerned about what is being done. So without worrying about details of implementation of the components. So at the abstract level, when in abstraction, basically at the abstract level, we are concerned about what would be the functionality of the component, and we are not concerned about the implementation details. That means how that functionality will be achieved, that is not the concern here at the abstract level. Hence it is also known as an outer view. Abstraction is necessary when a problem is divided into smaller parts. Whenever we are following problem partitioning as a design principle, abstraction becomes very necessary. Abstraction can be functional or data abstraction. Abstraction can be further divided into two subcategories, which is your functional abstraction and data abstraction. Now, talking of the first category, that is the functional abstraction. In functional abstraction, we specify the module by the function it performs. So basically, in functional abstraction, we are concerned about what function a specific module or a specific component is performing. Then comes the second category of abstraction, which is data abstraction. In data abstraction, basically this kind of an abstraction forms the basis for object-oriented design. You all know object-oriented design encapsulates objects and classes. Objects are basically instances of the classes. So in object-oriented programming paradigm, there is object-oriented design, and whenever in such a paradigm you are designing, that means you are doing object-oriented design, then data abstraction becomes important. In data abstraction, data is hidden behind functions and operations. That means we are concerned about the data, right? We specify what data will be used instead of specifying what functions or operations that particular component will perform. So we are here concerned about the data that a particular component or module will be using instead of what function or operation that component will be performing. So basically, we are kind of concentrating on the data. A system consists of components called modules, which have subordinate modules. Now, if there is a module and if we divide it into smaller modules, those smaller modules that are basically extracted from this bigger module are known as the subordinate modules of the main or bigger module. A system is a hierarchy of components, and thus when we divide a module into smaller modules, we get a hierarchy of what? Modules or components, and the highest level module, which is the module from which you have derived other subordinate modules, the highest level module, which is called the superordinate module. So basically the module from which the subordinate modules have been derived will be called the superordinate module, and this module corresponds to the total system. To design such a hierarchy, there are two approaches. One is the top-down and other is the bottom-up approach. So basically, whenever we are dividing a module into sub-modules, so there is a hierarchy, as I told you, and to design such a hierarchy of modules wherein you have a superordinate module followed by these subordinate modules, to have such a hierarchy, the two approaches are used. One is the top-down design approach and another is the bottom-up design approach. Now, if we talk of the top-down design approach, this approach starts by identifying the major components of the system. Basically, top-down means starts from top and ends at down. So at the top, as you know, is the superordinate module. So we identify the major components of the system starting from the main module or the superordinate module, such that it is divided into their own subordinate level modules or components, and in doing this procedure until the desired level of detail is achieved, where we can no longer divide a subordinate module into its own subordinate modules. So till that level we keep on doing the iterations of dividing the module or components into its subordinate level modules or components until we can no longer have a subordinate component or module. So it starts with a stepwise refinement, which starts from an abstract design, and in each step the design is refined to a more concrete level until we reach a level where no more refinement is required and the design can be implemented directly. That means we can have no further iterations. This is the basically approach in a top-down design. Now, if we take an example of library information system. To better understand the top-down design, if we take an example of library information system, then you can see here that if I consider the library information system, it can be for, if it is the main module or if it is the superordinate module, then the subordinate modules are data entry, queries, processing, reports, and at the end you quit or log out. So basically within a library information, what all functionalities can be provided? One is data entry, which is a separate module. It has got nothing to do with the queries or processing or reports module. Then queries is a separate subordinate module. Processing is a separate subordinate module. Reports and quit are another separate subordinate modules. Further, the data entry, which is a subordinate module in itself, can further be divided into a module called student member and faculty member, because data entry would be done for two entities. One is your student and faculty separately. So data entry can be further, which is a module, a subordinate module in itself, can further be divided into two other submodules, which are your student member and data entry and faculty member data entry. Then when we talk of processing in the library information system, processing can be done in two ways. One is issuing the books and another is return of the books. So that means processing, which is a subordinate module of the library information system, can further be divided into two modules. One is the issue module and another is the return module. So as you can see, both these modules, issue and return, are self-dependent and have no dependency upon each other. Similarly, these two modules, student and faculty, are self-dependent. They have no dependence upon each other. That means if you want to do data entry for student, you do not need to do the data entry for the faculty as well. Similarly, when you want to do data entry or any other operations on the faculty member data entry, you do not need to necessarily do the student member. So these are two separate submodules. They are self-dependent. Similarly, if we talk of these submodules, issue and return, they are also separate submodules. So when you have to issue a book to someone, you do not have to necessarily do the return from the same person. Similarly, when you have to take return of the book from some person, you do not necessarily have to issue the book to that person. So as I said, all the submodules are self-dependent, so you can clearly see here. Another submodule under processing submodule is your fine calculation. That means you calculate the fine. So all these are the submodules, and you can see the refinement is at the level wherein you cannot have further refinement. That means these modules can now not be further divided into any submodules. So this way, dividing the major component or the main module into submodules helps you to simplify the design process. So this is the hierarchy chart. The hierarchy that I was talking of is this in problem partitioning. This is the hierarchy chart of the library information system. So the main problem was designing a system for the library information system. And how do we go about it? We divided it into modules and further submodules, and now designing the system becomes easier for us, giving us a hierarchy chart. So this is a top-down approach. That means you start from top and you go to the bottom. So you start from here, you do iterations, divide this module into sub-modules, you further divide these modules into sub-modules. That means you're starting from the top and going till the bottom. Hence this hierarchy, this way of having hierarchy of modules and sub-modules is known as the top-down approach. So top-down design strategies basically work well for systems that is made from the scratch. That means when you are not improving an existing system, rather building a completely new system, in that case the top-down design approach goes very well. The other kind of design approach, as we said, is the bottom-up design approach. Now from the name itself, it is clear that here the designing goes from bottom to up, unlike in the top-down where we started from the major module and then went down iterating that module into sub-modules until we could have any further refinement. But in bottom-up design approach, it is clear that we start from the subordinate modules and then move on up to the main module or the superordinate module. In bottom-up design, we start from the bottom and move upward towards the top of the software. So here the software development begins with the lowest level components of the system. That means from the lowest level submodule and progresses upwards towards the higher level component, which is your superordinate module, which is basically the opposite of top-down approach, which we just saw. Now the weakness of this method is that we need a lot of intuition, because it is easy to divide a module into submodules, but it is not that easy to combine various submodules to get a superordinate module. So that means we need to have intuition in that case to decide the functionality that is to be provided by each subordinate module, which will lead us to the main or the superordinate module. Now this approach is more suitable if a system is to be built from existing system. That means we are improvising the existing system instead of building a completely new system, because an existing system starts from some existing modules, so we have some idea or picture of the sub modules and the superordinate modules. Hence in that case it is easier to go from bottom to up.